Once we have run our GPC samples, to get started, we'll go to the Analysis window and open our standard chromatograms by doing File, Open Chromatogram, and we'll first see the sequence that was run, starting with a blank of THF, followed by 3 standards, each in duplicate, and 2 unknowns, each in duplicate. We'll first open just our standards for the first injection. Now with any data, of course, before we start the analysis, we'll need to integrate. If we go to our peak method, we'll have a representation of that chromatogram above, and we'll first click the test button to see how the integration would apply. In this case, it looks pretty good for the first 2 peaks. Of course, the third is integrated. However, we do not want to integrate this noise at the end. And the simple way to eliminate that is to select Function and Lock. And in this case, we can turn the integration off after 23.6 minutes. We can keep that integration off until minute 27. And now, if we hit the check button, we'll see that we have our integration just for the 3 peaks and not the noise. We can now save this as integration, or whatever you'd like to name it, and we can then close it. The next step is to apply that integration to all 3 of our standard chromatograms. To do so, click Peak Process, and of course we're looking at channel 1, as you can see. We'll select the integration method we just created, and at the very top we'll select Apply to All Loaded Chromatograms, and now hit Execute. If there was any integration done previously, it will warn you, making sure you want to override it, which in this case we do. We now can close, and we see the integration for this chromatogram, for the second, and for the first, all of which look good. Now that we've integrated, the next step is peak identification based on molecular weight. We go to the peak ID table, and in this case, we click the Auto Write button, which, as you see, will fill in our retention times. And now we just need to name our molecular weight for each peak based on retention time. Of course, we'll know these as they are standards, and I will fill them in, as you can see. Now we can save this. As peak ID. And now we can close it and go to our second chromatogram. We will go back to peak ID and open that, and again click Auto Write. And again we have 4 new peaks that we simply need to name based on retention time. We will save this again, can close it, and open the third one. Click Auto Write, and our last set of peaks will be entered, and again we need to name them. We save, and we're finished with the ID. Now again, we need to apply that to all the chromatograms by clicking Peak Process, and down below we select our peak ID that we just created, and of course Apply to All, and click Execute. Now if we close, and we go through, we'll see all of our peak names have been applied to the chromatograms. Now the next step is to build our GPC calculation editor. To do so, go to the molecular weight calculation method. And what you'll see here is two different tabs, our calibration curve and our calculation parameters. We'll first start with the calibration curve, and we'll open our ID table. What that will do for us, after we select the correct channel, of course, channel 1, we'll fill in our peak names and our retention times. Now in here, we're going to simply enter in the actual molecular weight, which of course corresponds to our peak names. Now we filled in all of our molecular weights, and we can now go to the molecular weight calculation parameters. Now we have two options here, manual calculation and automatic calculation. We'll first start with manual calculation. Of course, we'll use peak area as opposed to height, and we'll leave the threshold 0 as that's where our signal is. We can ignore child peaks and have no limitation if we'd like. Now down below, we'll first start by entering int the baseline set range by right-clicking and selecting the range. Now in this particular case, it is the baseline, so we'll want to have that baseline wider than the area we want to use for the calculation by simply clicking to the left of the first peak and to the right of the far right one. It will enter in those values for us. If we'd like to type them, we can also do that. Next, we'll set the calculation range by right-clicking and setting the range. Again, we click on the left and to the right. However, in this case, we know if we scroll through, we have a peak much further to the right, so we want to make sure we have this range covering all of our peaks. If we scroll back through, we see that all of our standards are within that calculation range. The next thing to type in is our baseline type, whether it's connecting, horizontal, or backwards horizontal. In this case, we'll select horizontal. You see a slight baseline shift, very simple. The next thing to fill in is our division. We can either type in a number of divisions, so a number of slices, or we can just tell it to do a certain number by time, which is what we use in this case, of 0.1. So every 0.1 minute, it will take a division. And lastly, polarity, of course, as you can see above, is positive. Now we can also enter in a molecular weight range if we want to learn the percentage of our particular molecular weight. In this example, maybe we'll look at from 100K to 400K and see what percentage of our unknown is going to be in that range. So if we type in 100,000 to 400,000, it will give us our range once we apply this. At this point, we're ready to save this molecular calculation editor. So we save as manual. And we now can close that. Now to apply this, to build our calibration curve, as well as calculate the unknowns, we're going to go to the recalculation sequence. If you have a sequence already there, simply highlight each of the lines, right-click, and delete. Once we have cleared our recalculation sequence, we'll want to open the sequence that we're going to recalculate by selecting File, Open Executed Sequence, and in this case we only have one sequence available to choose. In this particular sequence, we of course have other samples that were run that we're not going to recalculate at this time. Simply right-click on the number and you can delete them, as we'll just be focusing on the first injection of all the samples. And what you'll see is we have our three standards, the first injection, and the first injection of our two unknowns. And the first piece of information to enter is the type. The type, as you can see, is either unknown or standard. Your first standard will be standard 1. Your second standard, standard 2, and your third standard is standard 3. Your unknowns, of course, will be unknowns, as those are not used in the calibration method. We'll next select the peak ID table. If you left-click, drag down, and then right-click, if you select Open, you see we're going to enter in our peak ID table that we've already created. And the last step is to tell it which molecular weight calculation method to use. We've already created one of those that we'll put into the data processing method. To do so, click Process, and the very first data point, standard number 1, we're going to set up as new molecular weight calibration curve. If our molecular weight calibration curve method has been used in the past, it will already have a calibration method with data points, other standards. To delete those and start fresh, we select New. Channel 1, of course, is the one we're using in this example. And then the parameters, we select the actual molecular weight calculation method that we previously created. We'll save this as New. We can then close it. And again, for the very first, standard 1, we will select that New. Now for standards 2 and 3, it'll be slightly different. In our data processing method, we will now select Add. So in this case, it will add these two standards to the curve. Select channel 1 again. And as always, our manual molecular weight calculation method that we've created. Save as, Add. And now, for standard 2 and 3, we'll use the Add. Now for the two unknowns, again we'll use a slightly different data processing method. Now, as we've only integrated the standards, we'll of course first want to integrate our unknown compounds. To do so, select Peak Find, channel 1 of course, and in this case we'll use our integration peak method that we previously created to integrate our standards. And now, for calculating the molecular weight, we'll actually use Calculate Molecular Weight as opposed to New and Add for the standards. Again, as always, channel 1 in this example, and we select the same calculation method. And we'll call this UNK for unknowns. We will then add that for our unknown samples. And what you'll see is the very first one is the New. The next two standards are Add and Unknown for the unknowns. Of course, if you have additional standards or unknowns, the same rules apply. The first of which, standard 1, is always New. Any additional are Add, and any known are unknown, of course. Once we've done that, we click the Run button. You see it's recalculating. And now what we can see, if we go back to our chromatogram, of course the standards will show no change as we've already integrated and named them. However, if we select File, open chromatogram, and we open our unknown, number 1 and 2, first injection of course. We'll see, of course, they're integrated now as we put that in the data processing method. And if we go to the molecular weight calculation results, we'll get our molecular weight calculation information. As you can see, it's telling us this particular unknown has a molecular weight of 198,000. And you can see all the information below in the table. Now, if you recall, we wanted to know the percentage of a particular molecular weight range from 400,000 to 100,000. For this particular sample, 62% is in that range, based on the area. If we look at unknown number 2, we'll of course see a slightly different view as it's a different sample. In this particular one, 158,000 at the peak top. Our range, about 90%, is within 400,000 to 100,000. And as you can see in both, the pink is our molecular weight calibration curve, each dot, of course, pertaining to a standard point. We can right-click, copy to clipboard, any of this information. We can also export to Excel, the table below. Now that we've learned how to do the molecular weight calculation using manual mode, let's go back and change that to auto. Go to the molecular weight calculation method, and we'll open the manual one we previously created. We'll of course see our calibration curve as well as the data points below. And we're simply going to go to the calculation parameters and change that to automatic. Now, in automatic mode, we need to set the retention times of our unknowns. So we'll first go back to the first unknown. If we right-click and say set retention time, we simply go to the peak top and set that. The division, again, we have the number of divisions or time per minute, and we'll use time per minute at 0.1 as we did in the previous example. As we have two unknowns, we go to the second, set our retention time at the peak top, and also set time division 0.1. We'll change our percentage just to show a different example here. We'll say 300,000 to 200,000. Now in auto mode, that's all we have to set. As building the calibration table is exactly the same. We'll now save this as auto molecular weight calc, and we can close that. If we go to the recalculation sequence, we used the manual mode previously, so we'll have to create slightly different data processing methods for the auto. Again, we'll select new for the first one. Again, channel 1. And in this particular case, of course, we'll now select our newly created auto calculation method. We'll save this as new auto. Next, we can create our add for standards 2 and 3. Of course, using our same auto method on channel 1. And now we save as add auto. And lastly, for unknowns, we'll first find the peaks just in case they have not been integrated. Of course, in this example they have already, but we'll create this anyway. And then we'll calculate the molecular weight of those unknowns, again using the auto method. We'll save this as UNK auto, and we can close. Now we'll fill in the table New Auto, Add Auto, and Unknown Auto. Now we simply click the Run button again. It will recalculate for us based on this auto molecular weight calculation. And now we can go to our results, and we'll see for the second unknown, again 158,000, just like we saw before. All the same information below, except of course our range changed, so now we only have 9% in that particular range set. If we go to unknown number 1, we'll get the information for that one, 198,000, and about 20% in that particular range. Now the last thing to learn in the GPC mode of ChromeNav is reports. We of course previously have gone through report styles and printing, but we'll go through because we want to add the new GPC functions. So we'll go to Edit Report Style, as we've done in the past. And in this case, of course, if we remember, we can enter a title or text. We can enter chromatograms and peak information tables with areas and heights and retention times. We can enter in the methods, the integration method, the control, how the HPLC was running, or in this example, we'll just go straight to the molecular weight calculation section. And as you can see, we can put in the curve by double-clicking. You can make it wider. Of course, this is just a representation, not the actual curve. We can change the fonts and colors, the plot colors and backgrounds, as well as other attributes, such as annotation or peak tops. We can enter in the distribution curve, the parameters, the calibration points, and other information as well. The slice data, and of course maybe the results of that molecular weight calibration. Once we've created our method, we of course will save that. And we can then apply and print that as we have in the past. To print that report style, simply select the chromatogram you want to print the reports for. Click Print Report Style and select that particular report style that we just created. You can also do that by File and Print Report Style and selecting. Now the last thing to learn is to make this a completed automated function. So we can have the system run the samples, as of course we've done previously, and then it can automatically do all the calculations that we've just learned in this section. We're going to first start by going to the recalculation sequence and show you how to do this. So when you're running samples, we of course want to build a sequence. And if we move this down, we can see both the recalculation as well as this new sequence that we're going to create. Now in the recalculation sequence, from sample to control method, it is all information that was entered when the samples were run. We, of course, then entered the type, the peak ID, and the data processing method in order to calculate the results for the unknowns. Now we're going to simply copy the information that was entered in when the samples were run. We'll simplify the names: Standard 1, Standard 2, Standard 3, Unknown 1, and Unknown 2. The acquisition time, 28 minutes for all of them, and the control method that was used was polystyrene. Now we'll enter in the same information that we entered in the recalculation sequence so that it will first run our samples, and then it will apply all of the methods that we've just learned so that when we come back after the samples finish, we'll have the molecular weight calculation results for the unknowns and can simply print them. So the type again In the recalculation sequence, we could have used unknown for all the types. I simply put in standard 1, 2, and 3 in this case, just as they match the names. So in this case, we'll just put them all as unknowns, as it just simply labels them for us. In the peak ID table, of course, we'll have to enter in the peak ID. And lastly, the data processing method, which of course is different for each one. If we open our new auto, which we'll use, the one thing we'll want to make sure in this case, as these are going to be new run samples, if we click the ... and say edit, we haven't put in our peak integration. So we'll simply peak find, channel 1, and put in the integration peak method that we created. And now we'll save that. We'll open the auto for adding, and the same thing here. We'll want to edit and have it find the peak or peaks using our integration method, and we'll save. We'll enter that for standard number 3. And then for the last two, the unknowns, we'll of course select unknown auto. Now if you recall in this one, we already had peak find in there, so it will integrate. So at this point we can save the sequence as whatever you'd like to call it, the date, complete automation of molecular weight, or whatever you'd like to call it. Now what will happen is, of course, it will actually run this 5 samples, and for each one, it will integrate, name the peaks, and then build a calibration curve, and then for the unknowns, use that calibration curve to actually give you your molecular weight calculation results. At this point, it's a complete function so that you can simply run samples, do all the data calculation for you, and you simply just come back and look and see how the results turn out, and print them if you wish.